I'm Randy Reed, editor of the Edison Report, and this is Lightfast. Today we are joined by Jordan Augustin, the president of the lighting division of Landscape Forums, and we're here to talk about solar lighting. Jordan, welcome.
Thanks, Randy. Great to be here.
Well, we're glad you're here. And the first question is solar lighting has traditionally been thought of for off-grid or remote areas. How is that changing today?
Well, in a couple of ways, Randy, I think one of the most interesting ways is that solar is really being thought of as ways to solve problems. So when thinking about things related to resiliency, so making sure there's illumination in public spaces when the grid is knocked out, for example, due to storms and whatnot. Also looking for ways to reclaim and reuse brownfield sites. So places where, trenching is not advisable or possible. And just as importantly is, sensitivity to the environment in terms of causing the least disruption possible.
Did you say brownfield areas? And I'm not familiar with that term.
Yeah, so in thinking about reusing previously industrialized sites, so that may have to go through an extended period of reclamation and solar lighting with its simplified installation process allows the introduction of site lighting in an easier and sort of less complicating fashion.
What are some of the key misconceptions that lighting designers and municipalities have regarding solar lighting opportunities?
Solar has been around for a long time, and I think with that being the case, there are a lot of baked in impressions of what solar used to be. So it used to be considered, sunbelt, perfect conditions were required. And today, high performance solar technology, such as is featured in our 360 solar collection, means that solar can be used in more places whilst providing reliable illumination.
So, battery performance has always been, I think, the gating item regarding
Mhm.
solar use. What technology improvements have we seen recently that are improving the battery life?
There's really three key improvements. So one is that energy density has gone up. See, the amount of energy stored per cubic inch, if you could think about it in that way, has gone up pretty dramatically, which means the batteries can be smaller. The temperatures the batteries can be efficient at has also widened. So they can now run in hot climates as well as cold climates. And importantly, the third point is that costs have come down. So in large part due to the dramatic increase in global manufacturing capacity, really driven off the back of the electric vehicle industry.
Okay, tell me about management algorithms and how they affect system autonomy.
Yeah, the ability to control the system is really key. You're working with a finite amount of energy, what's in the battery, and what you can collect on a daily basis in terms of energy from the sun. So being able to use that energy efficiently is really important, but also being able to respond to the local conditions. So, for example, if there is a period of cloudy conditions over a week or so, the system needs to know that to manage the output so that you never are left in a situation where the batteries run down to zero and there's no light coming out of the luminaire.
Okay, so battery technology dramatically improved. How close would you say we are to being able to use solar lighting year round in all climates?
I think we're there today, Randy, honestly. So to create our 360 solar collection, we partnered with Soluxio, who is a Dutch manufacturer and expert in solar technology. And they've really, in particular, developed an expertise in number one, the algorithmic management of the system. So from a local condition standpoint, it works very well. And equally in far northern climates where in the winter months, you have a dramatically reduced number of hours. So all of those parts and pieces combined means that we're really able to deliver illumination, performance grade illumination throughout the entire year, even in far northern conditions.
Okay, so let's speak realistically. Let's take Seattle. Right now, it's cold and rainy and miserable in Seattle. Um, what kind of life am I going to get out of your products this week in Seattle? What kind of light output? How many hours a night?
You'll experience illumination throughout the full nighttime cycle. So from dusk till dawn, if that is your desired program, then it will run. I mean, here in Michigan, which is where I'm calling you from, we've been running a 360 solar system for several years, and Western Michigan is well renowned for the a lot of cloud during the winter months, and we've continued to see excellent performance throughout the entire winter season, this one and the last several winter seasons. So we're seeing temperature stability on the battery. We're seeing consistent light output for the duration of the evening hours. Now, of course, during the winter, we will see overnight the ability to dim down during the wee small hours of the evening to manage that output. But we're seeing consistent light delivery throughout the entire night, every night.
So, how are manufacturers and designers collaborating together?
I think we're really at an interesting moment where the selection of solar as a solution to a site problem no longer comes with the aesthetic trade-off. I think one thing that most people have in their minds when they think about solar is the big square panel and the box on top of the pole that just yells, "Hey, this is a solar product." With the miniaturization of batteries and with the cylindrical panel designs, such as in our 360 solar system, you really don't have that aesthetic trade-off anymore. So you get the high performance that you expect from a modern solar luminaire and a beautiful design aesthetic, which I think is where, for landscape forms, that is very much the sweet spot. It's performance, it's design without compromise to deliver an outstanding result.
All right, talk about maintenance. What kind of maintenance is required? How long are these batteries going to last before they need to be replaced? And are they easy to replace?
Yeah, great question. I mean, to start with maintenance, there really isn't anything to do from a maintenance perspective. If, for example, you were in say, a coastal location where maybe there's a lot of salt spray buildup on the panel, maybe that necessitates an annual clean, but otherwise there's really nothing to do. The thing to think about long term is a battery replacement, and in that sense, you're really looking at 10 plus years. And I say 10 plus years because part of the algorithm that's running every single day is to minimize the depth of discharge in the battery. And that ultimately is what determines the battery life. So the system itself is optimizing not only light output, but also maximizing system life. So you could be looking 10 years, 15 years out into the future before needing to replace the battery.
So, as lighting designers begin specifying this, what should they keep in mind? What principles do they need to think about when specifying solar lighting?
If solar is the solution to the problem in terms of resiliency, in terms of site-specific installation challenges, clean energy mandates, difficult access to the grid, then solar can really be a terrific solution. From a designing standpoint, maintaining a clear southerly aspect to the panel and matching the luminaire wattage to the panel size. Like those are really the two details to monitor.
Okay, as we wrap up, tell us a little bit about what end of life planning looks like for these batteries.
Yeah, it's a great question. So there continues to be two really interesting areas that industry is developing. One is battery recycling, and the technology around that continues to advance, and particularly as electric vehicles step ever closer to end of life, that will, the capacity to recycle batteries will continue to increase nationally. The other, I think, even more interesting part is battery reuse. So, whilst a battery may, as we might consider it to be end of life from an illumination perspective, it still has capacity, it still has use in other applications. So industrial uses and others could very well see not just batteries from a solar lighting product, but EV batteries be redeployed in industrial and other applications.
Well, it sounds very exciting. Jordan, thank you for taking this time to educate our audience about
You're welcome,
solar
Randy.
lighting.
Thank you very much.